everybody, how's it going? Stoner Dave here, and yesterday I put out a video. I was talking about how stupid it is that Detroit Wanker calls the 7806 voltage regulator a transistor. And he seems to think that when I said I was admitting to being wrong about something, I was admitting to being wrong about that. But no, I was admitting to being wrong about it having reverse polarity protection. So putting it in reverse would damage it. However, you wouldn't get the results that you got from Detroit Wanker's mistake. But he's still trying to say it's transistor. And he put up a little image on there saying, looking at the 7806 transistor, and it's looking at it. And you can look at his own video thing image there. And it actually says several times, integrated circuit, IC, IC. Never says that it's actually a transistor. But what I have here is actually the schematic diagram of the IC involved in there. And there are actually 22 transistors inside 7806 circuit. So it's not a fucking transistor. It's a fucking voltage regulator. Voltage regulators are never transistors. They are voltage regulators. They have 3 terminals like a transistor, except they have a V in, a ground, and a V out. Not a gate, source, and drain. Not a base, collector, and emitter. They have V in, V out, and ground. That's 3 terminal. You also have 5 terminal voltage regulators, which I'm sure if he got one of those, he wouldn't think, oh, it's a transistor. But, you know, we are talking about Detroit Wanker. But to show you exactly that it is not a transistor, I have here a schematic diagram of one of the 7806 voltage regulators. This particular one is the H7806A, which is a 3-terminal positive voltage regulator. Anything that says 7806 is going to be a regulator. It's going to be the 6-volt regulator. Input voltage, 35 volts. Sound familiar? It's because they're all the same circuit. They're just sold by different manufacturers. So this one is exactly the same as the LM7806, which is the same as the HC7806, which goes on and on. There's so many different ones, but they're all the same thing, right? So without ado, check this out. So this is the internal circuit of the 7806. As you can see, you have a V in, you have a V out, and you have a ground. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 transistors on this. There's actually 22 inside the chip. If you look at the other data sheets, this is just the first one I came across that has a schematic on it. And yeah, the schematic is not complete. There's a reason for that, because they do not want you to be able to replicate this circuit on your own, right? It's because they have to do little bitty changes for each version so that they can put it out and sell it themselves. This is from High Sincerity. Others are from Texas Instruments. You can see here, there's a whole list of 6-volt positive regulators here, right? Here's the LM7806 right here. Look at this. The family of monolithic fixed voltage regulator integrated circuit. See that? Integrated circuit. They're suitable for applications that require a supply current of up to 1 amp. Many of them will go up to 1.5 amps as long as you have proper heat sinking. This is just giving you details about it. Oh, look at this. Another fucking circuit drawing. Application circuit. Typical application. It's all in the fucking data sheets. See? Not a transistor. Let's look up some transistor data sheets. I'll just go here. Let's go get some, click search. I might have to close this before it'll start looking for another one. Yeah, probably. I'm gonna do that. See, this is a little app that I got that allows me to look up data sheets. 2N901. Look at that. A whole bunch of them, right? Let's just look at the first one. Holy shit. That's just giving me max limits on there. Cool. Let's see. Get to actual. Then I gotta go through all these junk fucking listings here before I can find. Here we go. Look at this. See that? What's it say? Transistor. This is a transistor. Not a voltage regulator, a transistor. I was looking for something that would actually include the symbol for it as well, but it didn't have that. Maybe, oh, there we go. Here we go. Look, internal structure. This is it. See, the other one had a whole fucking schematic diagram. This just has this because it's just a transistor. One transistor. Not an integrated circuit. It's just a transistor. Halogen free. NPN general purpose amplifier. See, this one refers to it as an amplifier. But it's a transistor. Transistors can be used for amplifiers. They can be used for switching. So let's see here. They got current gain. You can see that. DC current gain. Saturation voltage. Metasaturation. Noise figure. Input capacitance. Output capacitance. Here we go. Fall time. Short time. Rise time. These are all characteristics that are used when using the capacitor or the transistor as a switch. You have delay time, rise time, storage time, fall time. That's how much time it takes for it to turn on and turn off. In integrated circuits, you'll often see a slew rate being used, but when you're dealing with a voltage regulator, you're just dealing with maintaining voltage at a certain current. That's it. So I wasn't saying that I was wrong about your integrated circuit not being a transistor. I was saying I was wrong when I said that it had voltage protection on it. Reverse voltage protection to be precise. Because it doesn't, right? And I admit to that. But that's not what I was talking about in the whole fucking video that I did. I was talking about how you didn't put it in backwards. You hooked your voltmeter up improperly. I wasn't talking about how it would or wouldn't work because it was put in backwards. I was talking about how it's not a fucking transistor. If I put an NPN transistor in backwards, right? I connect to the emitter instead of the collector and the collector instead of the emitter. It won't work. But as long as I'm within the regular voltages, I shouldn't have too much problem with it as far as being able to work, as long as I don't push it too far. You know, if I hook it up with 12 volts on the collector or the emitter and ground at the collector, yeah, I could do some damage to that thing, right? But if I only hook it up to, like, say 3 volts, I notice it's been backwards, I take it off in time, I probably won't have damaged the the transistor. Hard to say for real, you know, because I've honestly never done that. I mean, I've fried a lot of transistors in my day. I mean, even just last week, I fried a couple right here because it was short, right? And they fried really fucking quick. So luckily, transistors aren't very expensive. You know, I can get, well, this whole fucking pack of, what is it? 24 values, 240 different transistors. Well, 24 different ones, 10 of each, so 240 transistors for less than $10, right? Pretty good deal. I also got this other package here of, this one has got 40 of each with 1, 2, 3, 4, 1, 2, 3, 4, 5, 24 different transistors, 40 of each. So do the math. And yeah, $16. You know, they're cheap. Like, you can get them a dime a piece, but the more you buy, the less they cost, blah, 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 blah. Same thing with the regulators, really. I mean, the more you buy, the less they cost, but you typically don't need more than one at a time, right? So you pay a little bit more for the one that you need, and then you don't. But if you're like me and you're doing multiple things at the same time, you may want to buy these things in bulk. Now, I have a lot of the 3904s, 3906, because they're so common. The ones I have less of are the less common ones, but I have some of almost every transistor. Every once in a while, I'll come across something that I don't have a transistor that fits the need, and I'll go look and find a good deal on getting them, and I'll buy them either like this with a whole shitload of other transistors to resupply, or I'll buy just however many I feel I might need of that particular transistor. The way I look at it is, if I see it once, I'm going to probably see it again, right? And if I see it again, I'm probably going to see it a bunch of times. So I have a lot of transistors that I've never seen, just in case I see them, right? I try to keep a good supply of everything. But while I'm talking about it, when you're dealing with these types of regulators and transistors, because there's a lot that come in this particular package, right? When you're dealing with them, the proper way to put them in is to bend the leads like so, and you should have a place to solder this down and solder it to the mat. This is a surface mount application of a similar. You see the leads go right here. Actually, the center one doesn't actually get put down, although it's got a terminal for it. Center one is actually connected to this one right here, but neither here nor there, right? Sometimes you have to use a heat sink. Heat sink goes on to this thing, and a lot of times the chassis will be used as the heat sink, and you'll put this onto the chassis. You'll see in a lot of builds, the regulators will go along the edge of the board, so that you can use the chassis as a heat sink. Also, since the pin that's connected to the heat sink there is connected to ground, it's also a good way to ground your chassis, in case you were wondering, right? So yeah, transistors can be used as either an amplifier or a switch, right? So voltage regulators can be used for neither of those applications. So let's look up, what is a transistor? Question mark. Transistor is a semiconductor device that controls the flow of electrical current and voltage in electrics. Transistors are fundamental components of modern electronics and are used in devices like smartphones and computers. Transistors have two main functions. Show more. Amplification. A transistor can increase the strength of an electrical current by using a small input current to produce a larger output current. Switching. A transistor can act as a microscopic switch to turn an electrical current on or off. Transistors are made of 3 layers of semiconductor material, each of which carry an electrical current. They were originally made of germanium, but most are now made of silicon because silicon can withstand higher temperatures. Transistors are considered one of the most significant technological breakthroughs of the 20th century. They allow for the development of devices like personal computers and smartphones. Now, if I go in and I look, what is a voltage regulator? A voltage regulator is an electronic device that maintains a constant output voltage regardless of fluctuations in the input voltage or load conditions, essentially ensuring a steady and reliable power supply to connected circuits. It achieves this by adjusting its internal circuitry to compensate for voltage changes. All right, and there's other key points, functions, like show more. Primary role is to provide a stable voltage to sensitive electronic components, even when the input power source experiences variations. Applications. Voltage regulators are commonly found in various electronic devices like computers, power supplies, car alternators, power distribution systems. Mechanisms. They use different methods to achieve voltage regulations, including feedback loops, internal adjustments to current flow, etc., etc. Now, the final question. Is a voltage regulator a transistor? Transistor. Question mark. No, a voltage regulator is not just a transistor, but rather a circuit that typically includes a transistor as a key component to control the output voltage, along with other elements like a reference voltage source and feedback loop to maintain a constant output voltage. Essentially, a transistor is used within a voltage regulator circuit to achieve the regulation function. Now, I'm going to go ahead and show this to you, but I want you to breathe that in for a bit. No is the very first word in the answer. A voltage regulator is not just a transistor. Transistor is a singular fucking component. It's got 3 layers of semiconductor, but it's one component. Inside this big block of plastic here, there's only one transistor connected to these 3 long leads. Inside of this transistor, there's only one transistor, and this is a much bigger package. Why is it a bigger package? Well, it's a power transistor. It's designed to handle a lot of current. I don't know what the model is on this. My eyes aren't that good, and I don't have the lights on in here, so it's not exactly easy to read, but tip 31C. Tip 31C. These are made to handle current more than voltage. 3906 is made to handle voltage more than current. That being said, this handles voltage too, right? You can't have one without the other. But with the 3906, if you try to put more than, I think it's 125 milliwatts, put more than that going through it, it'll overheat and burn up, where this one can handle 3 watts. I believe it's 3 watts. I'd have to look at the data sheet, but I believe it's 3 watts on this guy. But there it is right there. Voltage regulator is not just a transistor. Now I'm going to show it to you right now. There you see it. Main function is constant output voltage when the input voltage or load current fluctuates. Right? So what that means is if you put a low impedance on there, it'll maintain that 6 volts, which is what Detroit Record did when he put the fucking voltmeter on and had it in current read mode. He put a real low impedance on there, high current. The thing was trying to output the 6 volts. It kept the 6 volts on that low end. What happened though is the high end ended up going up to 10 volts. And he should have realized, oh shit, I got something creating a short on this side because it's reading 6 volts when they should both be reading 6 volts. If he hadn't had that short over there, that maybe 1.5, 2 ohms of resistance. I mean, really, when you got your meter and amp meter, the better the meter is, the lower that impedance is. Mine here is like a $10 multimeter. I got it at 8, but it's like a $10 multimeter, and it's got 1.6 ohms in current read mode. And if I put that in parallel with something that's putting out 6 volts and I have another circuit on the other side, I got 2 parallel circuits. I lower one. Yeah, that one might go down to 6 volts. The other one probably end up going up to 10. And of course, he's given an approximation because he's got everything turned off at this point in time, right? So it is what it is, bro. Now, I seen that you sent me a picture of a top view of an amplifier asking me to tell you what the problem is. I'll tell you what the problem is if you want to send me a schematic and tell me a little bit about the issue that you're getting. I mean, you're saying it's not passing signal. So my first thought when I'm hearing not passing signal is broken solder joint, right? It's the first thing that comes to my head. It's not passing signal. There must be a break in the solder joint. But that's not necessarily the case, right? You'd have to do a little bit, probe around a little bit, and of course having a copy of the schematic would help. And I'm not going to go through all that trouble for free, right? So the one thing I will tell you is that I could tell it's a homemade amp, and I could tell it was an amp that you made yourself, and you're just looking for somebody to try to give you some ideas how to fix it. I have confidence that you'll be able to figure that out with all the resources that you have at your disposal. But for me to do it, you'd have to send me the amp, and I would expect at least 20% of my charges up front. So decide on what you consider a fair value and what you're willing to pay to have the amp shipped to and from my home. And yeah, I'll fix it for you. Don't expect it to be cheap, though. Just understand, I'm not going to tell you what's going on with it. And I'm especially not going to be able to tell you what's going on with it from an image that you posted up of your shoddy fucking workmanship and your fucking terminal post sticking from out of nowhere with all those fucking shoddy solder joints everywhere. I mean, sorry, bro. It's not my job to determine what you fucked up when you're building your amplifier that you're claiming is your friend's. And I know why you're claiming it's your friend's, because if it was yours, you would have demonstrated it by now. Right, sure. Yeah, it was one of your attempts to not do a kit, right? You're like, oh, I'm not going to do a kit. I'm just going to copy this fucking thing from the kit, put terminals up on all the holes, and look at the schematic to put it together. I get it. I could say the same thing about this, right? Put it on a breadboard. I mean, the switching here, that's a pretty common circuit. I picked the resistor based on what we need to control the current on the LEDs for the collector resistor. The base resistor and the capacitor are chosen to pick the time. This is close to a second for each light, so take with it what you may. I think it's 47K or 470K, and the capacitors, maybe 10 microfarads. I don't know. I'd have to look at them. And like I said, I don't have my lights on in here, so it's a little bit hard to see numbers and shit. I don't have my glasses on to read. I got this, but values aren't on my side, so it is what it is. But given the 470K, you should be able to figure it out yourself, right? I mean, you know how these things work, right? So is what it is, right? And then the amplifier there, that is my design. Going from essentially a buffer all the way up to I believe 10. No, it was more than 10. Oh, let me get my calculator here. I'll give you an idea. That gain range. So approximately 80 times. That it's, that's an approximation. It's more like 70 times, but that's gain, not distortion. And I hear your friends just talking about how your amplifier's got all that distortion on there and call it a high gain amplifier, but it's not necessarily high gain. I mean, it's high distortion, especially with those clipping elements in there, right? You put a clipping element in there, you don't have to have as much gain to get clipping. And I heard you turn the clipping element off and saying how the clipping element made the volume go down a lot, but when you turn that clipping element off, I didn't hear a substantial decrease in volume. I really didn't. But that's probably because you don't understand what gain is, and I get it. It's not something that you're learning very much of on your YouTube lessons there. It is what it is, though, right? So, from this video, I hope you've learned. Sorry, I was getting over a little bit of a sore throat there. But from this video, I hope you've learned, if nothing else, a voltage regulator is not a transistor. Although you can make a voltage regulator with just one transistor. Perhaps I could demonstrate that. Let me see if I can. I don't know what I can use for various levels of inputs. And I honestly don't know if I have a Zener diode laying around. But I do have plenty of transistors here. Let me go see what I can find out.